Alright, so on number 29 here, we need to write this in logarithmic form. So notice here we have the three parts that we've talked about before. The 64 is what we call the base. The 1/3 is the exponent. And I've been calling the 4 the answer. So we're going to switch to logarithmic form. You want to first write log. And the base is going to be next. We're going to put it as a subscript. That would be the 64. The answer goes here. And we know that a logarithm is an exponent. So the exponent, which is 1/3 in this case, will go by itself. And that's always the case when you're in log form. The exponent goes by itself. The other thing is I always like to go in reverse just to double check it. So 64, oops, I forgot to do that. Let me go back. 64 to the 1/3 power equals 4. I call that around the world, but when you check it, you do have 64 to the 1/3 power equals 4, which is what we started with, and so we're good. And so that is our answer. So on number 30, now we're going the opposite direction. And so we can do the little around the world thing. 3 to the x plus 1 power is 15. And that's what we have here. Let's look at 31. So now we're going to graph this. First thing I'm going to do is write that using a y. And so this is the graph that we need to come up with, but we want to start by graphing the parent function, log base 4 of x. And choosing x values for this can be kind of challenging. You have to really know your logarithms. I think it's easier to just go ahead and write this in exponential form. And now instead of picking our x's to be -1, 0, and 1 like we did with exponential function, we're going to let y be -1, 0, and 1. Notice if you plug in 1 for y here, 4 to the 1 power is equal to x, that's 4. If we plug in 0 for y, we'll get 1. And we know that we should get the reciprocal of 4 here, and that would be 1/4. Or you can just plug in -1 and you get 4 to the -1 does equal 1/4. So here's my points. And I have an asymptote that's vertical right along right on the y-axis. And we learned this is the graph I want you to know for the logarithmic functions where the base is greater than 1. It's always going to have this shape. It's always going to go through 1, 0. So it looks something like that. And so we just need to move that graph. Let's see, because of that +3 there, we're going to go left 3. Because the 3 is inside with the x, it causes a horizontal shift, and that's left 3. So we need to move our 3 points left 3. And notice the horizontal asymptote will also move. So anytime you do a horizontal shift, it'll change your asymptote for a logarithm. So here that would be x is equal to -3. That's our asymptote. And from the graph you can see the domain is -3 to infinity. Whoops, I forgot my negative there. And the range is all real numbers. Notice you got to be careful here to draw that part correctly, because otherwise you may not see that it goes to infinity. It continues to rise even though it's kind of slow. Alright, let's move on to 32. So here we're solving a logarithmic equation. We've got 2 logs on the left, a subtraction of 2 logs. We're going to want to use one of our properties of logs. It's what we call the quotient rule. We know that the log of a quotient is equal to a difference of logs. Here we have a difference of logs, so all we have to do is write this m over n and make this into 1 log. And so in our problem, it's going to be x plus 4 over x minus 2. So because of the subtraction, we're going to have a division of those 2 numbers, x plus 4 and x minus 2. On the other side, we have 2. Now, if this were log equal log, we don't have log 2 of 2 over here. If that were the case, we would just set these equal, but that's not what we have. What we do have is something that we can switch forms with. This is logarithmic form. We have our base of 2 here, our exponent, remember base, exponent, answer. Let's go ahead and change this to logarithmic form. It'll be 2 squared is equal to x plus 4 over x minus 2. So 2 squared is 4. We're going to need to multiply both sides by x minus 2. And so on the right, we're going to get x plus 4. We got to also multiply the left side by x minus 2. It'll be 4 times x, which is 4x, and 4 times a minus 2, which is minus 8. And now we just need to get x by itself on one side. So we're going to have to get rid of that x on the right. So let's subtract x on each side. We get 3x minus 8 is equal to 4. Let's get rid of the minus 8 by adding 8 to both sides. We get 3x is equal to 12. And that means x would be 4. Let's go ahead and plug that in here. Log base 2, 4 plus 4 is 8. Minus the log base 2, 4 minus 2 is going to give us 2. And that's equal to 2, or at least we want to check to see if that is. Log base 2 of 8. So what exponent do we put on a base of 2 to get 8? That would be 3. What exponent do we put on a base of 2 to get 2? That would be 1. 3 minus 1 does equal 2, so this does check. All right, on number 33, getting ahead of myself here. We're going to use the change of base theorem. Basically, this is a base other than 10 or e, and so it's got to be written as a division of, well, using the change of base theorem. It's basically the log of the higher number over the log of the lower number. So this will be the log of 4.35 over the log of 2. And if you put that into your calculator just like it looks there, you should get 2.110. Now, remember, a logarithm is an exponent. So as you look at this, this represents the exponent that you put on a base of 2 to get 4.35. So the answer we got, if we take 2 to that power, it should give us 4.35. And you can see that you can double check it. It does work. All right, so in number 34, we're just putting each of these into the calculator. So you should get for the first one 3.1250. So it's kind of interesting because you're going to hit ln and then second ln in order to put the e to a power. So be careful there. On the other hand, remember our base is e here. You could actually do this one without a calculator. What exponent do you put on a base of e to get e to the 3.125 power? Well, that's just 3.125. So that's also another way you could do this problem. Log of 500, you should get a 2.6990. The log of 2150 times e to the 0.04 times 3. You know, just be careful here that you put this in using the caret symbol and then do 0.04 times 3. If you don't use the parentheses there, depending on your calculator, you could end up having problems. So in this problem here, we end up getting 2424.1182. The last one, similar to C, you're going to have to be careful how you put that in. You're going to put in the 1300 parenthesis 1 plus 0.07 divide 12 into parenthesis, and then you'll put your caret symbol and 5 times 12 in parentheses, or you could just say to the 60th power. So just be careful how you put that into the calculator. You should get 1,842.9128. All right, let's move on to number 35. All right, so it says solve the following system by graphing. All right, so we have to graph two inequalities. What we want to do, one of the things we do when we do this type of problem is we're going to have to put in the point of intersections. And so let's go ahead and find those first by looking at the equal case here, when y is equal to 9 minus x squared and y is equal to 2x plus 1. Since these are both equal to y, in other words, if y is equal to 9 minus x squared, and if y is equal to 2x plus 1, then we could set these equal since they're both equal to y. So that's what we're going to do. So when we set these equal and we get our solutions, that's going to tell us our points of intersection. So this is a quadratic equation. I'm going to go ahead and subtract 9 on both sides and add x squared because I want my x squared term to be positive. So I'm going to get 0 on the left. On the right, the x squared should go first, and then the 2x, and then notice 1 and negative 9 give you the negative 8. When you factor this, you should get x plus 4 and x minus 2, which means x equals negative 4 or 2. Now, that's just the x value of our points of intersection. So we need to find the corresponding y values. If x is negative 4, I'm going to go ahead and use y equals 2x plus 1. We could use either equation here. So let's plug in negative 4 for x. 2 times negative 4 is negative 8, plus 1 is negative 7. If we plug in 2, our other solution for x, we get 2 times 2 plus 1. We should get 5 there. So our points of intersection are the following points. When we chose x to be negative 4, we got negative 7. When we chose x to be 2, we got y equals 5. These are our points of intersection. Now, what we want to do as we graph y is less than or equal to 9 minus x squared is first graph the equal case. So I'm going to go ahead and do that. I'm going to go ahead and put the minus x squared first. Now the parent function here is y equals x squared. Oops, it's not letting me write there. There we go. So y equals x squared. Whoops, let me go backwards here. Y equals x squared would look like this. But we have a minus in front of it, so it's actually going to look like that. But we got to move everything up 9. So basically we take these points that we would get on the graph of minus x squared and move all of those up 9. So let me erase this, just kind of briefly telling you where I got my graph from. It's going to look like that. Now we also know that negative 4, notice 2, 5 is one of those points. Negative 4, negative 7 is also on the graph. Now because we have an axis of symmetry, we know there's a point the same distance on the other side. So right at 4, negative 7. So let me erase this here. I'm going to put it in a little bit nicer. So it looks like that, and our graph looks like that. That's the graph of y equals 9 minus x squared. Now the thing is, we're wanting to graph y is less than or equal to 9 minus x squared. Well, the actual graph itself is where y equals 9 minus x squared. That's going to be part of my solution. And then also anything less than that. So we want to shade below the graph. So it's going to look like that. So that's the graph of y is less than or equal to 9 minus x squared. Now let's go ahead and graph y equals 2x plus 1. And then we'll graph y is greater or equal to 2x plus 1. So our y-intercept here is 0, 1. Remember we get that from, whoops, let me not do that. we're getting that from here. 0, 1 is our y-intercept. Of course, our slope is going to be 2. So we're going to, again, you want to use a rise and run here. So you're going to go up 2 and right 1. And notice if you go up 2 and right 1, you'll be at 2, 5. We could also go down to left 1, down to left 1. And so notice you get that point there. And we could go down to left 1, down to left 1, down to left 1, and sure enough, we're at that point, -4, -7. The line looks like that. Now that's part of my answer because notice it says y is greater or equal to 2x plus 1. So the equal part is the line itself. So if we want to shade where y is greater than 2x plus 1, we want to shade above the line. So let's go ahead and do that. Actually, I'm going to go ahead and put in my points of intersection there. I want to shade above the line. And so finally, our solution is the region that these two areas have in common. So that would be what's in here. So finally, just to make things really clear, I'm going to shade my boundary, and then this area that I just shaded is part of my answer here. So let's go ahead and do that. We'll darken up our points and along the line and the curve. So where I've shaded, I should say where I've darkened and made it black here, that's the boundary. That's where we're equal in both systems. And then what I've shaded is the remaining part of the solution. All right, let's move on to 36. All right, so it says solve the following system. We've got to do this without a graphing calculator. We can check it on a graphing calculator, but I need to see your work. So I would use elimination here. You could use substitution, that would also work. But notice if we multiplied the second equation here by by 3, we would get opposites for x, so that when we add the equations together, we would eliminate x. So we sometimes call it the addition method. That's because we're adding the equations together. We call it the elimination method because when we do that, we should either eliminate x or y so that we can solve for the other variable. So let's go ahead and rewrite the first equation, and let's multiply the second one by 3. So I'll get the minus 3x that I want. 3 times 3y is 9y, and 3 times 18 is 54. Some people like to do something like this. Whoops, boy, that's not very easy to see. There we go. In any case, we're multiplying each term by 3. And so now let's go ahead and add these equations together. When we do eliminate x, we're going to get 10y on the left and 50 on the right. And so y is going to be 5. All right, so next we can use either equation to find x. Let's go ahead and use the first one here. Let's plug in 5 for y. So we need to solve for x here. We'll subtract 5 on both sides. We're going to get 3x is equal to -9. And divide by 3, and you get -3. So our final solution here is the point -3, 5. I want to remind you that you could plug that into both equations and it should make the equation true. You can do that on a calculator in less than 30 seconds, so it's a good idea to check your answers. On number 37, I think I'm actually going to do that one on a separate video because I'm just about out of time here. Let's go ahead and stop right here.